Hello everyone. In this video, I am going to share my PhD interview experience in the Nanotechnology department of IIT Guwahati. There are 4 members in the interview panel, and my interview started with my academic introduction. Then after they asked me, what is your MSc project? I replied that my MSc project is graphene. Then he told to say something about graphene. That I replied, graphene is a 2D monoatomic crystal. It is a single layered structure of carbon atoms where each carbon atom is sp2 hybridized with other 3 carbon atoms. It is a honeycomb lattice structure and known as the semi-metal or zero band gap semiconductor. Because its valency band and a conduction band meet only at 6 direct points. In graphene, 3 electrons out of 4 valency electrons of carbon atom make sp2 hybrid bonds with other carbon atoms, that is the sigma bonds, 3 sigma bonds. The remaining 4th electron make pz orbital which oriented perpendicular to the surface. The pz orbitals, these pz orbitals make weak bonds, pi bonds, which is responsible for all notable electronic properties of graphene. Then graphene is the strongest, thinnest and lightweight material. It is a very good conductor at low temperature. Then he asked me, okay, which branch of physics is required in studying graphene? I replied that solid state physics is the branch, but he said solid state physics is not a fundamental, they also depend on another branch. Then which branch is that? But I could not answer it. He replied that quantum mechanics is more fundamental and used in studying graphene. Then he started asking questions from quantum mechanics. First question there, he asked me that what is the difference between infinite and finite square well potential. I replied one of the difference between infinite and finite square well, that in case of finite square well potential, bound states exist, but in case of infinite square well potential, there is no such bound states. Then he asked what are the bound states and unbound states. For bound states, there is no degeneracy, but there is degeneracy in case of unbound states. Then he asked me what is degeneracy. I replied what is the degeneracy. Then he asked me if degeneracy is present, then what will be the wave function. Then if degeneracy is present, then the wave function has mixed symmetry. That is the case of unbound states. But if there is no degeneracy, the wave function must has definite parity of either even or odd. This is the case of bound states. If degeneracy is present in the wave function, then the wave function, when operated by different operators, it will give the same eigenvalue. This is all about my experience in PhD interview at Nanotechnology department of IIT Guwahati. Thanks for watching.